Hello and welcome back. All of us are prone to lights, whether it be normal obsolete filament bulbs or ubiquitous LED lights. But do we actually know the types of lamps available and the measurement unit of light intensity? And can we make our own light intensity meter? So hang on, in this video, I will not only talk about light intensity units and measurement, but we will also talk about creating our own light intensity meter, which is very cheap. So let's start with the build. So the main unit of measuring light is lux or luminance per unit area. It is equal to 1 lumen per square meter. There are other units like lumen per meter square and candela which can also be used. There are basically five main types of lamps. First is the incandescent lamp, also known as tungsten filament lamp, in which current passes through a wire filament or a tungsten filament that illuminates the surroundings when voltage is applied between electrode 1 and electrode 2. Now this has become obsolete. Second type is the halogen lamp, which is basically similar to incandescent lamp or an offspring of incandescent lamp. This lamp has high power and provides ultra bright light. The filament inside is coated with quartz and filled with halogen gas like bromine or iodine. The third type is the gas discharge lamp. Gas discharge lamp has neon gas filled inside an enclosure with two electrodes which discharge when voltage is applied between the two electrodes. The fourth type is the fluorescent lamp, which is quite difficult to understand. It consists of a mercury vapor filled inside a glass tube whose inner wall is coated with materials that fluorescences. When mercury atoms collide with cathode electrode, UV radiations are emitted. We will talk about fluorescent lamps in great detail in our future videos, but for now, fluorescent lamps are nothing more than the tube lights we use in our homes. It consists of a starter, ballasts, mercury vapor, two electrodes, and a power of electricity. The last one is the xenon flash lamp, which is a gas discharge lamp which I have explained in great detail in one of my videos. I will provide the link in the I button. Now we will create our own light intensity meter which senses the intensity of light. So first, to sense the intensity of light, we have to use a transducer, in our case a LDR, a light dependent resistor whose resistance changes with light intensity. Now using a voltage divider of 50 kilo ohm and LDR, we will convert the resistance values into some useful voltage value, which will be 3.5 volt initially. The voltage divider is connected to the inverting input of the comparator IC and the non-inverting input is connected to the other set of voltage dividers. And when the light is incident on LDR, the resistance of LDR decreases, so does the voltage at the inverting terminal as the LDR forms the voltage divider at inverting terminal. And the output goes high, which means the non-inverting terminal's voltage exceeds the inverting terminal's voltage. When more light is incident, the other comparators turn on and the LEDs glow according to the intensity of light. If the full light incident, the 4 LEDs glow, and if less light is incident, maybe 1 or 2 or 3 LEDs glow according to the intensity of light. Then after the theory out of the way, I started creating it practically on the piece of breadboard by first fixing the voltage dividers, then the ICs, and finally the LEDs and the transistors which would switch the LEDs according to the command of the IC. But there's one question: how can we measure the light intensity accurately? So, for that, you can refer to the datasheet of LDR, which gives you tons of information. But for now, we will look at the resistance versus the lux chart, which is very useful for understanding the light intensity. So, as you can see in the chart, the light intensity is highest when the resistance is approximately equal to zero point 0.1 ohm or nearly 0 ohm. So we can conclude that the resistance decreases with the increase in intensity of light. The another chart of luminosity is also important. The highest luminosity is of sunlight around 30,000 lux and the least is of the moonlight around zero point 0.1 lux. But now finally after everything worked out, it was time to create the enclosure or housing for the meter. So I took a white box which was basically scrap and marked the distance for fitting the LEDs, gathered all the components, started soldering them on the prototype board, and the build was complete. So after building it completely, measuring and testing it, you can see that the intensity of light is directly proportional to the level of LED it glows. If green LED glows, it means that the intensity of light is less. If red, the intensity of light is a bit higher. If orange, the intensity is even higher, and if white, the intensity is maximum. So that our meter works perfectly, but it's not that accurate or it's not that precise that the ones we can buy in market, but it works fine and it is very cheap also. First of all, thanks for watching, and what are you waiting for? Hit the bell icon and stay tuned for more videos like this.